In the early hours of April 12, 1970, a single red flare rose from the conning tower of a dying submarine in the Bay of Biscay. The men watching from Soviet rescue ships knew what it meant. Seconds later, the stern slipped under, the bow tilted skyward, and the submarine slid backward into the Atlantic, accelerating as it fell, carrying 52 men and 4 nuclear torpedoes nearly 5 kilometers to the ocean floor. It was the largest peacetime naval exercise in history. Over 200 warships across 3 oceans. The Soviet Navy's moment to prove it had become a global superpower. And in the middle of it, a nuclear submarine had just gone down with enough plutonium aboard to contaminate a fishery for longer than any civilization has lasted. The fire that killed those men started on April 8th, but the fire was not the cause. The cause had been documented 10 years earlier, studied, written up in engineering reports, detailed enough to prevent every death that followed. The Soviet Navy took those reports and classified them, sealed the lessons in files no submarine crew would ever be allowed to read. 9 months later, the same failure killed 8 men on a different boat. A decade after that, the same design flaws killed 52 on the boat that had provided the warning in the first place. Every death aboard K-8 was preventable, and the proof had been sitting in filing cabinets the entire time. To understand what those men were sailing inside, you need to understand a decision. In 1954, the Americans launched USS Nautilus, the world's first nuclear-powered submarine. Nautilus proved that a boat running on atomic reactors could stay underwater indefinitely. No surfacing, no snorkeling for air, no vulnerability. The Soviet Navy had nothing equivalent, and in the logic of the Cold War, nothing meant extinction. The response was Project 627, codenamed KIT, the Russian word for whale. The program was forced into existence under political pressure that treated engineering timelines as ideological weakness. The Kremlin wanted nuclear submarines, and it wanted them immediately. What arrived at Sevmash shipyard were production quotas, not safety standards. The engineers delivered exactly what was demanded: boats that were fast, powerful, and built to break. The November class could do 30 knots underwater. That was the only number the men in the Kremlin cared about. Everything else bent around it. The twin VMA reactors that powered the boats produced enormous energy but ran on cooling systems with margins so thin that a single cracked pipe could start a chain of failures no crew could reverse. The reactor shielding was cut back to save weight. Technicians working in adjacent compartments absorbed low-level radiation during normal operations. Every patrol, every shift. The massive coolant pumps that kept the reactors from overheating vibrated constantly, and because Soviet engineers had not yet mastered the vibration-dampening mounts the Americans were already using, those vibrations transferred directly through the hull and out into the ocean. Every November-class submarine announced itself to anyone listening. The American SOSUS hydrophone network, a grid of sensors laid across the Atlantic floor, could pick up a November-class boat from hundreds of miles away. The submarines built to challenge NATO's dominance of the ocean could be heard crossing it. The noise was not just a tactical liability, it was a survival problem. Inside the hull, the constant mechanical drone from the reactor compartment masked the sounds that a crew depends on to understand what their own ship is doing. Subtle changes in pipe pressure, shifts in pump rhythm, the first faint hiss of a steam leak, the acoustic warnings that a well-designed submarine communicates to its operators were drowned out by the machine itself. The boat was too loud to hear its own emergencies beginning. The Americans, after losing USS Thresher in '63, built an entire safety certification program around preventing exactly these kinds of cascading failures. They called it SubSafe. It mandated quality controls on every component that touched seawater, metallurgical traceability for every weld that held back the ocean. The Soviets built more submarines instead, and then there were the cartridges. Every submarine needs breathable air. The November class generated it with canisters of potassium superoxide, superoxide, designated RP200. The chemistry was simple. The canisters scrubbed carbon dioxide from the atmosphere and released oxygen in return. In a controlled environment, they worked. In a fire, they became something else entirely. Potassium superoxide is one of the most aggressive oxidizers in industrial chemistry. When heated, it doesn't just burn. It feeds pure oxygen directly into the flames, turning a containable fire into one that cannot be extinguished by any means available aboard a submarine. Western navies had moved to electrolysis-based oxygen generators specifically to avoid this. The Soviets kept the cartridges. They were cheaper. They were simpler. They were aboard every nuclear submarine in the fleet. K-8 was the third November-class boat built. She was commissioned in August 1960. Within weeks of entering active service, she proved exactly how dangerous her own design was. On October 13, 1960, while operating in the Barents Sea, a pipe in one of K-8's steam generators ruptured. Primary coolant, water that had been cycling through the reactor core absorbing the heat of nuclear fission, began pouring into the reactor compartment. It flashed into radioactive steam on contact with the air. The temperature in the reactor core started climbing toward the threshold where uranium fuel rods deform, crack, and melt. A full meltdown, submerged, in Arctic waters. The crew had no automated system to stop it. The early November-class boats had no redundant emergency cooling, no backup loop that could take over when the primary failed. What they had were men willing to walk into a compartment full of radioactive steam and solve the problem with their hands. Engineers pulled on whatever protective clothing they could find, gear designed for chemical spills, not reactor emergencies. They opened the hatch to the reactor space and stepped into air thick enough to taste. The steam carried fission products, isotopes ripped from splitting uranium atoms, invisible and accumulating in their lungs with every breath. They worked in relays, minutes at a time, rerouting coolant around the ruptured pipe, bypassing the failed system with improvised connections, feeding water directly into the reactor core to bring the temperature down before the fuel rods crossed the line between damage and catastrophe. They held it. Degree by degree, the core temperature dropped. The meltdown stopped. The dosimeters aboard K-8 could not measure what those men had absorbed. The instruments maxed out. Later medical assessments estimated that 13 crew members had taken doses between 180 and 200 rem, enough to guarantee long-term health consequences for every one of them. 3 showed immediate radiation burns, the kind that appear within hours when the exposure has been severe enough to destroy tissue at the cellular level. The submarine limped home to Severodvinsk, Severodvinsk, on diesel power, with a cold reactor and a crew that was alive only because a handful of men had agreed to trade their futures for everyone else's present. What had just happened was a catastrophe. It was also a gift, not because the outcome was good, but because the data was extraordinary. A Soviet nuclear submarine had experienced a near-fatal coolant failure, and the crew had survived to document exactly what failed, exactly how the systems collapsed, and exactly what needed to change to prevent it from happening again. The engineering reports were detailed. The recommendations were specific. The evidence was paid for in radiation burns and contaminated blood. If you're watching this far, drop a comment. It tells me you want to hear how this ends. The Soviet Navy took that data and classified it. Not partially, completely. The incident was sealed under military secrecy protocols that treated equipment failures as state vulnerabilities. Acknowledging that a nuclear submarine had nearly melted down weeks after commissioning would have exposed weaknesses the Kremlin could not afford to show. So the engineering reports were restricted. The safety recommendations were filed. The lessons that K-8's crew had purchased with their bodies were locked in cabinets that no other submarine commander, no other reactor engineer, no other crew in the Soviet fleet would ever be permitted to open. 9 months later, on July 4, 1961, the ballistic missile submarine K-19 suffered a nearly identical failure. A pipe in the primary cooling loop cracked, radioactive coolant poured out, the reactor temperature climbed, and the crew of K-19, who had never been told what happened on K-8, who had never seen the engineering reports, who had never been briefed on the improvised bypass that had saved the boat 9 months earlier, had to invent the same solution from scratch, inside the same lethal conditions. They welded pipes together in a compartment saturated with radiation so intense that the men who entered it absorbed doses of 5,000 to 6,000 rem. 8 of them died within weeks. Their skin blistered, their bone marrow failed, and they died in military hospitals while the documents that could have prepared their crew sat in a restricted archive. K-19's own sailors gave her a name after that, Hiroshima. The pattern was now visible to anyone allowed to see it. 2 submarines, same generation of reactor, same cooling system vulnerability, same improvised repair, same crew heroism under identical conditions, 1 classified, 1 producing coffins. The classification of K8's incident did not prevent a repeat, it guaranteed one. Every piece of data that could have redesigned the cooling system, that could have added a redundant backup loop, that could have trained K-19's engineers before they needed the training, was locked in a filing cabinet while the men who needed it died solving a problem that had already been solved. K8 was repaired, her steam generators were replaced, she returned to active service by 1963, but the repair addressed the symptom, not the disease. The reactor design was not fundamentally altered. The cooling system that had nearly failed catastrophically retained its single-point vulnerabilities. The RP-200 cartridges were not replaced with safer alternatives. The ventilation system, the same system that would later carry carbon monoxide through the entire length of the boat, was not redesigned with isolation dampers that could seal individual compartments from shared air supplies. The compartmentalization doctrine that treated sealed hatches as the answer to every emergency was not reconsidered in light of what those same sealed hatches had nearly done to K-8's own crew. The Soviet Navy had received a warning written in radiation exposure and contaminated blood. They filed the warning, fixed the broken pipe, and sent the submarine back to sea, carrying every vulnerability she had exposed, intact and unaddressed. For 7 more years, K-8 operated. She patrolled the Barents Sea. She deployed to the Mediterranean, shadowing American carrier groups, slipping through the Strait of Gibraltar submerged at 140 meters beneath the acoustic shadow of Soviet surface ships to evade NATO detection grids. She was a workhorse doing dangerous work with a design that had already tried to kill her once, and the flaws she had revealed in 1960 were still inside her when she was ordered into the Atlantic in the spring of 1970. The exercise was called Okean 70, OKAHN. Admiral Gorshkov's Gors HHK OFAF personal project. He had spent years arguing that the Soviet Union needed a navy capable of operating anywhere on Earth, and Okean 70 was his proof of concept, the largest peacetime naval maneuver in history. Over 200 warships, 80 submarines, hundreds of aircraft, coordinated across the Atlantic, Pacific, and Indian Oceans simultaneously. Every available submarine was deployed. The exercise was designed to simulate global war against NATO. It was also designed to be watched. Western intelligence monitored every movement. Gorshkov wanted them to see what the Soviet Navy could do. K-8 had been at sea for 51 consecutive days when the exercise placed her in the Bay of Biscay, 300 nautical miles northwest of Spain. 51 days of continuous reactor operations, continuous demand on electrical systems, continuous strain on equipment that had been designed for speed, not endurance. The crew was fatigued, the machinery was fatigued, and the exercise schedule did not include provisions for a boat to withdraw because its systems were aging. There was no mechanism for a submarine commander to say the boat needed rest. Gorshkov needed numbers. K-8 was a number. On the evening of April 8, 1970, at approximately 22:30, electrical short circuits ignited simultaneously in 2 compartments. Compartment 3 housed the sonar and acoustic command systems. Compartment 7 contained critical propulsion controls. The fires started in cable insulation and pooled lubricating oil. In Compartment 3, the crew fought back with foam extinguishers and managed a partial suppression. Toxic smoke, dense with carbon monoxide, drove them out, but the fire was contained. Compartment 7 was a different story. The fire reached the RP-200 cartridges, the potassium superoxide ignited, and the oxygen it released turned the compartment into a furnace that sustained itself. Every attempt to smother the flames failed because the fire was generating its own oxidizer. It consumed bulkheads, it destroyed hydraulic lines and electrical mains, and it entered the ventilation system, pushing carbon monoxide through ducts that ran the length of the submarine, reaching compartments that weren't burning, filling them with poison that the men inside couldn't see. Captain Basonov, B.S. Ochonov, ordered an emergency blow. The ballast tanks emptied and K-8 rocketed to the surface. But surfacing only traded one crisis for another. The fire in Compartment 7 was beyond any suppression capability the submarine carried, and the damage control protocol that was supposed to protect the crew began killing them. Soviet doctrine demanded that burning compartments be sealed, airtight. The logic was sound in isolation. Contain the fire, starve it of external oxygen, protect the adjacent spaces. But Compartment 7 sat between the forward crew and the men stationed in Compartment 8 at the stern. When the hatches were sealed, the technicians in Compartment 8 were cut off completely. The fire warped the metal of the access hatches with heat so intense that the men on the other side could not force them open. They were locked in a sealed space while the ventilation system fed carbon monoxide through every duct the fire could reach. Both reactors were shut down. The port reactor scrammed automatically. The starboard was shut down manually by the engineering team in the final minutes before they evacuated the space. Without reactor power, K8 switched to diesel generators, her last source of electricity. The diesels overheated within an hour because their cooling water lines ran through fire-damaged sections of the hull. When the diesels failed, everything failed with them. The submarine went dark. No propulsion, no power, no pumps to control flooding, no radio to call for help. No ventilation to clear the gas that was still accumulating in sealed compartments where men were still alive. K8 was drifting blind in the open Atlantic, trailing smoke from her hull, with a Force 8 storm building on the horizon. When damage control teams finally cut through the warped hatches into Compartment 8 with heavy tools, they found 8 men dead from asphyxiation. They had been alive when the hatches sealed. They had waited in the dark for rescue that took hours to reach them because the fire between them and the rest of the crew could not be crossed. 15 more men were pulled out, breathing but with carbon monoxide poisoning so severe that their blood had lost the ability to carry oxygen. Their skin had turned the characteristic cherry red of lethal CO exposure. All 15 died within hours despite everything the remaining crew could do. The ship's doctor had given his own gas mask to an injured sailor during the initial evacuation. He died without it. 30 men were dead before dawn of the first day. The compartmentalization that was supposed to save them had sealed them inside the poison. The ventilation system that was supposed to keep them breathing had distributed the gas that killed them. Every safety system aboard K8 had functioned exactly as designed, and the design had killed them. K8 drifted for 2 days in worsening seas. Without power, without propulsion, without the ability to send a distress signal, she was invisible to the outside world. A hulk of steel trailing smoke, rolling in the Atlantic swell with the living and the dead still aboard. On April 10th, a Canadian freighter appeared. It approached close enough to see the Soviet submarine clearly, to see the men on the hull, to see the damage. It circled once at a cautious distance, then it turned away and continued its course at full speed without making contact. Whether the captain feared a Cold War entanglement or simply chose not to involve himself, no explanation was ever given publicly. Then the Bulgarian merchant vessel Avior appeared. K8 had no functioning radio, no signal capability beyond what a man's voice and a handheld lamp could produce. The crew communicated by megaphone and signal lamp across heaving swells, shouting course coordinates and damage reports into the wind. The Avior's captain understood immediately. He relayed a distress call through a shore station in Varna to Moscow. Admiral Gorshkov learned that his showcase exercise, the demonstration that was supposed to announce the Soviet Navy as a global superpower, had just produced the worst submarine disaster in Soviet naval history. 43 men were evacuated to the Avior in heavy seas, transferred by rubber life rafts that pitched violently between the two vessels. Then Soviet rescue ships arrived, including the repair vessel Komsomolets and the submarine K-83. And Captain Bessonov made the decision that would define the rest of the story. He ordered the evacuation, but when rescue ships appeared and towing became a possibility, he asked for volunteers to reboard K8 and prepare her for towing. Soviet naval code held that a commander does not abandon a salvageable vessel. 21 men volunteered to stay with their captain. They climbed out of the life rafts that had just carried them to safety and went back aboard a submarine they had fled hours earlier. They stepped onto a hull with no power, no propulsion, 2 dead reactors, and fire damage running through the stern. They knew what they were returning to. They went anyway. For 3 days, those 22 men lived on the exposed deck of a submarine that was slowly sinking beneath them. They worked to attach tow cables in seas so violent that the rescue ships could barely hold station alongside. When the first steel hawser was secured to the bow and the towing vessel took up tension, the line held for hours before a wave surge snapped it like thread. A second cable was rigged. It lasted less time. The problem was not the cables. The problem was the hull. Fire-damaged seals in the stern were leaking. Water was entering compartments that no pump could evacuate because there was no electricity to run the pumps. K8 was settling deeper with every hour. The trim was shifting aft. The men on deck could feel the angle changing under their boots. On the night of April 11th, the situation became terminal. The water entering through the stern exceeded any remaining buoyancy margin. The rescue ships standing by could do nothing more. There was no technology available to stabilize a submarine taking on water from internal damage in a Force 8 storm. The geometry was closing, and everyone who understood displacement and trim knew what was coming. Sometime after 6 in the morning on April 12th, someone aboard K8 fired a red signal flare into the dark sky above the Bay of Biscay. The crews on the surrounding rescue ships watched it arc and hang, then the stern went under, the bow rose, and K8 slid backward into the Atlantic, gathering speed as she fell, descending through nearly 5 kilometers of black water until the pressure crushed her hull with a sound the American SOSUS network recorded from hundreds of miles away. Captain Weswalad Bessonov, Versier Vorlad Bessonov, went down with his ship. He was posthumously awarded the title Hero of the Soviet Union. The disaster itself remained classified. 4 nuclear torpedoes settled into the sediment at 47 degrees north, 16 degrees west, in international waters at a depth of 4,680 meters. The warheads contain plutonium-239. Its half-life is 24,000 years. The steel casings that hold it corrode at roughly 1/10 of a millimeter per year in deep Atlantic conditions. The ocean will reach the plutonium eventually. The question has never been whether, only when. The IAEA monitors the site periodically. No one visits it. The Soviet Navy classified the K8 disaster, the investigation, and the engineering conclusions. The same institutional reflex that had turned K8's 1960 coolant accident into a death sentence for K19's crew now ensured that 52 more deaths would produce no change to the system that caused them. The reports were filed, the recommendations were sealed. The RP-200 cartridges stayed aboard every submarine in the fleet. 19 years later, on April 7, 1989, the submarine K278 Komsomolets, Komso Moh Lets, was cruising submerged in the Norwegian Sea when a fire broke out in the engine compartment. The blaze reached the chemical oxygen generation cartridges, the same cartridges, the same chemistry, the same chain reaction that had turned Compartment 7 into a self-sustaining furnace aboard K8 2 decades earlier. The fire fed itself with the oxygen the cartridges released. It overwhelmed the crew's suppression capability. It spread through the ventilation system. 42 men died. The submarine sank with a nuclear reactor and 2 nuclear torpedoes. Norwegian monitoring expeditions have since confirmed that the warheads are actively leaking cesium into the surrounding water. The contamination is measurable. The lessons from K8 that could have prevented it were in the files. They had been in the files for 19 years. The men aboard Komsomolets never saw them. They died solving a problem that had already been solved. Again, between 1946 and 1996, Soviet nuclear submarines suffered more than 20 major incidents. At least 758 crew members died. Fires, coolant failures, radiation emergencies, sinkings. The same categories of failure recurring across 3 decades of submarine operations. Each one investigated, each investigation classified, each classification insulating the system from the pressure to change that only public accountability can provide. K8 did not sink because of a fire. Fires can be fought, fires can be survived. K8 sank because a system designed to protect state secrets became a system that manufactured preventable death on an industrial scale. Every engineering report that was classified instead of distributed, every safety recommendation that was sealed instead of implemented, every lesson that was locked away instead of taught, purchased the illusion of institutional competence at the cost of the men who needed that knowledge to survive. The filing cabinets outlasted every submarine they buried. The decisions outlasted the men who made them, and the consequences, settling slowly into the sediment of the Bay of Biscay, will outlast everything. 52 men paid for that silence. The receipt is still on the ocean floor. The plutonium will be there for 24,000 years, and the files are still closed.